Hi and Assalamualaikum. My name is Farah Adibah binti Muhammad Zahir. We are from group FATA, and for my part, I will present about part 1 for this assignment. For the first question is A. State the reference where this probability function or density function is given. Okay, so here is the link that we have based on our reference, and we choose Pareto distribution function for our question. For B, find the estimated parameter of the function using the method of moments and the method of maximum likelihood. Okay, so for the first one, method of moments. Right, so here is the equation. Fx alpha beta equal to alpha beta power of alpha over x alpha plus 1. Ex equal to integration from beta to infinity, and then we times with x. And this is the function alpha beta power of alpha over x alpha plus 1 dx. We have alpha beta over alpha minus 1, and then equal to x bar. We will have beta hat equal to x bar alpha minus 1 over alpha. So this is the estimated parameter of the function for method of moments. For method of maximum likelihood, we add product before the equation, so we will have product alpha beta power of alpha over x power of alpha plus 1. We will have alpha beta alpha over x1 power of alpha plus 1 times with alpha beta power of alpha over x2 power of alpha plus 1, and until alpha beta power of alpha over xn alpha plus 1. Okay, so after we have that, and then we will simplify it, and it will become like this. And then after that, we will add a ln in front of the equation. So after that, we will differentiate the equation, and we have n alpha over beta, and then we will equalize it with 0. So we can see that it has no meaning. Since alpha over beta power of n is a decreasing function, it means the likelihood function will be maximized at the smallest possible value at beta. Since every si is less than beta or beta is greater than si, so L alpha beta will be maximized at the largest data point. So we have beta hat equal to max x1, x2 until xn, beta hat equal to xn. So it is the maximum ordered statistic. For C, determine the unbiased estimator of the parameter. Okay, so this is the calculation. E beta hat equal to E x bar alpha minus 1 over alpha. Okay, so we actually have E x bar. E x bar is alpha beta over alpha minus 1, so we substitute it in here. So we have alpha beta over alpha minus 1 times with alpha minus 1 over alpha. We will have beta. Can conclude it x bar alpha minus 1 over alpha is unbiased estimator of beta. For D, verify whether the estimated parameter attain a lower Kramer bound. Okay, var x bar alpha minus 1 over alpha is equal to alpha minus 1 over alpha square var x bar. Okay, so we will have var x bar equal to 1 over n square var summation of xi. Hence var x is equal to e x square minus ex everything n square. Okay, so we need to find this one. We need to find this one because we have ex, we don't have ex square. So we find ex square first. So after we integrate it, we have alpha beta square over alpha minus 2. Okay, so after that we have ex square, so we will put it inside this equation. So like this. Okay, var x equal to alpha beta square over alpha minus 2 minus alpha beta over alpha minus 1 square everything. Okay, so after we expand it and everything, we will have alpha beta square over alpha minus 2 times with alpha minus 1 square. Based on this one, 1 over n square var summation of xi, we have var x bar equal to 1 over n square var x1, x2 until plus with until xn. Okay, so 1 over n square times with n alpha beta square over alpha minus 2 alpha minus 1 square. So after that, we simplify it and it will become like this. We have var x bar alpha minus 1 over alpha. After we simplify it, we have beta square over alpha minus 2 and alpha, and then we need to find CRLB. We need to add ln fx alpha beta, so we have here, and then we differentiate it. We have alpha over beta. We differentiate it again. We have negative alpha over beta square. So we add e. We have the same thing actually, because we don't have x in this equation, so we will still have negative alpha over beta square, and then we add negative n. We have negative na over beta square. Okay, we need to power it with negative 1. We can get beta square over na. So what we have, var x bar is equal to beta square over alpha minus 1 and alpha is less than beta square over na here. So we can conclude that this indicates that CRLB is not applicable and beta hat is not UMVUE for beta.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rina Mazaki. I'm from FATA, and today I'd like to continue present about the data set that we choose and also the statistical analysis for the data set. So first of all, we decide to choose the data record of daily rainfall at Malacca, and we name the data as table 1. We do the analysis by distributing the data set of record of daily rainfall amount into 3 tables. And table 1 despite the recorded data, which include the data set of the amount of rainfall daily for each 12 months. Table 2 shows that the data of record of the amount of rainfall by 12 different months from January to December. Meanwhile, table 3 shows the output from RStudio using summary open bracket and close bracket to measure of central tendency and dispersion of the data set of each month, which include mean, median, quarter 1, quarter 2, standard deviation, variance, and also the percent coefficient to find the measure of dispersion. And lastly, the chart presents the box plot of the data set as the chosen suitable graphical method. So first of all, table 1 despite the record data from Jabatan Meteorologi Malaysia in 2019, which include record of daily rainfall amount for months from January to December, and 365 data collected with only 99 days rain and 266 days was not rain. And this is the output for the summary data statistics that we found out in RStudio. In table 2, we delete the data that has not recorded any value of rainfall. We can summarize that the most rainfall month for Malacca was in June, which include 15 days of rain comes, and also recorded the highest amount of rainfall, which was 113 on 11th of June, which was the heaviest rain. And also the lowest rainfall month for the Malacca was in January, which only recorded 4 days of rainfall. But the lowest record amount of rainfall was only 1 millimeter on November 8th and also 21 December. And this is the output of summary from table 2. So from this summary, we can construct the table 3. And from table 3, we can see the comparison of measurement of central tendency of the data collected. From the data, we had calculated all the median, mean, variance, and standard deviation and 3/4 for amount of the rainfall for each month. This is the output of the summary statistic we had get from the RStudio. So, we can also identify the skewness of each shape of distribution by plotting the box plot. So, from table 2, I decide to plot a box plot, so we can identify the skewness for each month, January to December. So, as you can see from this box plot, we can see that for month of January, February, March and also November is there are negatively skewed shape of distribution, and for the others month, April, May, June, July, August, September, October and also December has positively skewed shape of distribution. So from all the table and the analysis we get, we can conclude that the Malacca has the most rain in June with average 31.6 millimeter, and the driest month in February with average rainfall of 7.8 millimeter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ayu Farhana binti Ami Hamzah. I will be presenting for coding part, where we use R programming to find the normal distribution and also the exponential distribution. First, for the R to read our data from the Excel, we need to use the read Excel package for R to import our data from Excel to R. So we use library read Excel and our data will ready to use. To view our data, we can use view rainfall and it will appear our data over here. So firstly, we need to find the normal distribution. The goal here is to find the maximum likelihood estimate for our parameters, which mean and also standard deviation. So first we use the function and return function to find or to declare and define our likelihood function. Next, the optim function over here is to find the value for mean and also the standard deviation. So if you run this line, we will obtain the answer in the console, which value $par here is the value for mean and also standard deviation, and our mean is 16.3901 and standard deviation is 19.52217. For the dollar value here is our likelihood value, which represent the L. So our L value is 430.3085. And next, we can directly find our AIC value, and the formula is negative 2 times log L plus 2 times K. So L we already obtained from the previous function, and K is our parameters, which 2 mean and also standard deviation. So we can call our AIC value, and the answer is negative 8.129005. Next, for exponential function, we use this function to define the likelihood function, and the optim over here is to find the value for our parameter, which is lambda for exponential function. So we declare the optim into the result, and the result we can call the result to obtain the answer, and in this case the answer is our lambda is 0.06104398 and our L value is 372.0235. So we can find our AIC value directly, and our K value here is only 1 as our parameter is only lambda, and the AIC we obtain negative 9.837916. So for the log normal distribution, I will pass to the next presenter. Thank you. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. I am Nur Atifah Nadira. Now I will continue to estimate the parameters and finding the MLE for log normal distribution. Here I have named the function to estimate the parameters in rainfall dataset as NLL.logNormal. Then I use return function, and in return function I use RLNorm function because this is a log normal distribution. So rainfall here is the dataset that I use, and there are two parameters that I want to estimate. The first parameter is mean, and the second parameter is the standard deviation. Next, in order to optimize the log likelihood function, I use the command optim. Okay, here in the optim command, the first one here is the initial values that I use, 3 and 3.5, and then the second one is the log likelihood that I want to maximize, and the third one here is the data that I use, which is rainfall. So now I can run the code. The output here that I have is for the parameter. There are two parameters that I have since I want to find two parameters, and the first parameter is the mean, and the second parameter is the standard deviation. Next, the value here, it refers to our MLE value. In this case, it is negative 396.9687. Okay. Next, to find the value of AIC, I need to use the value from here, because the formula is negative 2 log L, which is our L is negative 396.9687, the value of our MLE, plus 2 times with K. K here is equal to 2 because we have two parameters, mean and the standard deviation. Okay, and then I can run the code. Okay, the output is NaN, which indicates that the value is impossible. This is because our value in the log function is negative, hence we cannot compute the value because it is negative. Okay, so in conclusion, we can find the best distribution by comparing the AIC values from the three distributions that we have calculated. But since our AIC value for the log normal distribution is an error, we can only consider the AIC values from normal and exponential distribution. And the exponential distribution gives the minimum value of AIC, which is negative 9.837916. Therefore, we can conclude that exponential distribution is the best distribution. So that's all from me and my group members. Thank you.